Hello students, welcome to this new mathematics session for grade 10. So we are going to continue with the topic of indices and standard form, and in this session you are going to learn how to write down a given number in standard form, and secondly you are going to learn how to evaluate a given sum and difference of two numbers in standard form, right? So we begin with writing a given number in standard form. The first example, it says write in standard form. First part, we have 470, right? Since 470 is a whole number, the decimal point is found completely at the end, right? So to be able to write this number in standard form, if you recall from the previous session, a number in standard form has to be written as a times 10 to the power of n, where a is a number between 1 and 10, right? And n is an integer. So the key here is to make the number 470 between 1 and 10. So we have to move the decimal to the left, 1 decimal place. So it's 47. Still we continue to move. So we have 4.70, which is between 1 and 10. This is okay. Then we need to multiply by 10 to the power of how many places have we moved? 2 decimal places in the left direction, so positive 2. Right? We have learned about this in the previous session, so it's just a recap. The second part, here we have a decimal number 0.023. So the decimal is here. We need to bring this number between 1 and 10, so we have to move the decimal this time to the right. 1 decimal place, 2 decimal places. So 2.3 is between 1 and 10. Then we multiply by 10 to the power of how many places have we moved? 2 places to the right, meaning negative. Okay. Third part, you have 17.5 times 10 to the power of 2. Right? Now just forget about the 10 to the power of 2. Right? Forget about it. Okay? Let us just focus on the 17.5. Okay? So here we have 17.5. We need to move the decimal to the left. So we have 1.75. It's between 1 and 10. Then times 10 to the power of how many places have we moved? 1 place. So in the direction to the left. So it's positive 1. Now all that we have to do is to combine these tens by using multiplication law of indices, right? So we write 10 to the power of 1 plus 2, it is 3. Okay, the fourth part, we have 0.064 times 10 to the power of 6. Again, forget the 10 to the power of 6, right? Concentrate on the 0.064. The decimal point is here, so we need to bring it till we obtain a number between 1 and 10. Here we are, 6.4. right? Times 10 to the power of how many places have we moved? 2 places to the right, meaning negative. Now all that we have to do is to combine these tens by using multiplication law of indices. So this gives 6.4 times 10 to the power of negative 2 plus 6, it is positive 4, right? So this is the first example, right? Especially the third part and the fourth part, you have to know it because we are going to use this in the coming examples, right? Now, how do we evaluate the sum in standard form? I will explain to you two methods. The first one, it uses ordinary form, and the second one, it uses factorization, right? Both methods, it is better for you to know both methods, right? So let us see this example. We have to evaluate the following, giving your answer in standard form. So the final answer has to be in this form, a times 10 to the power of n, where a again is a number between 1 and 10 and n is simply an integer, right? So the first method we are going to use ordinary form. So I have 2.8 times 10 to the power of 2 plus 3.2 times 10 to the power of 3. I need to evaluate this sum. This can be written simply as 2.8 times 10 to the power of 2 is simply 100 plus 3.2 times 10 to the power of 3 is 1000, right? 2.8 times 100. So 2.8 times 100. We include some zeros, then we move the decimal to the right by 2 decimal places, 1, 2. So it's 280 plus the second one, 3.2 times 1000. So I include some zeros, then I cut the zeros, I move the decimal to the right by 3 decimal places, 1, 2, 3. So it is 3200. Now simply I have to add these two numbers, 3200 plus 280, it gives 3480, and this number I convert it in standard form because the question says give your answer in standard form. So I have 3480, the decimal is here. I need to move the decimal till I reach a number between 1 and 10. 1 decimal place, 2 decimal places, 3 decimal places. So it is 3.480 times 10 to the power of, how many decimal places have we moved? 3 decimal places to the left, so positive 3. So this is the answer, 3.480 times 10 to the power of 3, right? So here we have used ordinary form to evaluate this sum, right? Now there is a second approach to this question. It's by using factorization, right? Some of you might find this a bit difficult, right? But you have to know it, because not always you are going to have questions involving small powers. What if you get questions involving large powers, for example power 12, power 20 and so on, right? Then it could be a problem to write in ordinary form. Okay, so let us see the same example but using factorization method now. Right, so we are given 2 decimal 8 times 10 to the power of 2 plus 3 decimal 2 times 10 to the power of 3, right? And 10 to the power of 2 is simply 100. 10 to the power of 3 is 1000. Now, if I ask you a simple question, which one of these numbers is common? That is 100 or 1000 is common. Which one is the common factor? Right? It's always the smaller number which is common, because 1000 is divisible by 100, meaning 100 is common, right? So 100 is common, meaning the smaller number is always common. Keep this in mind, right? Always the smaller number is common. So we are going to take out 100 or simply 10 to the power of 2 as common factor, right? This is how we identify the common factor, right? Always you take out the smaller number, which is going to be the common factor, right? So let us do it. Right, so we have said 100 or simply 10 to the power of 2 is common, right? So we have to take out 10 to the power of 2 outside, right? But first, what you do is simply you write the given question as 2.8 times 10 to the power of 2 plus, now the second number here, 3.2 times this 10 to the power of 3, you break it down. 10 to the power of 3 can be written in terms of 10 to the power of 2. It is simply 10 to the power of 2 times 10 to the power of 1. Because if you apply multiplication law of indices, you have to take 2 plus 1, which gives 3. Right? So this is a little trick here that you have to adopt. 10 to the power of 3, we write it as 10 to the power of 2 times 10 to the power of 1. You will see its advantage now. Here we can clearly see the common factor, which is 10 to the power of 2. In both numbers we have 10 to the power of 2. So we take out 10 to the power of 2 outside. So we are left with 2.8 plus 3.2 times 10 to the power of 1. Okay, we continue. This is 10 to the power of 2 times 2.8 plus, now this part here, 3 decimal 2 times 10. It is simply 32. Right? So let me continue the question here. This is equal to 10 to the power of 2 times 2.8 plus 32. So I have 32, I have to add 2 decimal 8. So this is simply 32 decimal 0, 0 plus 8, 8, 2 plus 2, 4. This is 34.8. Now 10 to the power of 2 times 34.8, it is the same thing as 34.8 times 10 to the power of 2. Now, is this our final answer? Remember, the final answer has to be in standard form. Is it in standard form? Let us check. Is the first number between 1 and 10? No, it is not between 1 and 10. So we have to bring this between 1 and 10. Right? So we keep the 10 power 2 like we have done in the first example. We bring this number between 1 and 10 by moving the decimal to the left by 1 decimal place. So it is 3.48 times 10 to the power of how many places have we moved? 1 place. Right? So let me write it here, 10 power 2. Now again we apply multiplication law of indices, and this becomes 3.48 times 10 to the power of 1 plus 2, which is 3. Right? So our final answer. You see, we have got the same answer, right, for the first part using 2 different methods. Okay, here 3.48 is the same as 3.480 because the 0 at the end you can ignore it. Okay, right? It's not difficult, the second method. You have to know it. Right? The factorization part, always keep in mind you have to take out the smallest number as common. Right? So let us take an example now where we have negative powers. We are going to apply the same principle. So this example again we have to evaluate, and the answer has to be in standard form. Okay. The first method we are going to use ordinary form. So we have 5.2 times 10 power negative 2 plus 4.2 times 10 power negative 3. Right? This is simply 5.2 times. Now, since the power is negative, if you remember the law of indices concerning negative power, x to the power of negative m, the negative power can be converted as positive if we take the reciprocal, meaning 1 over. Then the power becomes positive. Right? We are going to apply this here. 10 power negative 2, we take the reciprocal, 1 over 10 power 2. Okay? Plus, we do the same for 10 power negative 3 times 1 over 10 power 3. And this is simply 5.2 times 1 over 10 power 2, meaning 1 over 100 plus 4.2 times 1 over 10 power 3 is simply 1 over 1000, and this can be written as simply 5.2 over 100 plus 4.2 over 1000. Right? Now we convert both fractions as decimals. This is 5.2 divided by 100. You have learned this in primary level. 5.2 over 100. When dividing, we have to move the decimal to the left. So let me include some zeros there. 1, 2. So I move the decimal by 2 decimal places. So it's 0 decimal 0 5 2. Right? Plus I do the same for the second one. 4.2 over 1000. Right? So 4.2 over 1000. Let me include some zeros. 1, 2, 3. I move by 3 decimal places. 1, 2, 3. So it is 0 decimal 00 42. Now I have to add these two. 0 decimal 052 plus 0 decimal 0042. So this gives 26500. So this is 0 decimal 0562. And we write it in standard form by moving the decimal this time to the right. 1 decimal place, 2 decimal places. So it's 5.62 times 10 to the power of negative 2. Right? It's pretty easy. Now the same example, but using the second method of factorization. Right? So let's do it. So we are given 5.2 times 10 power negative 2 plus 4.2 times 10 power negative 3. Okay, again, for the method of factorization, we have to take out the smallest number. Now here we have 10 power negative 2 and here we have 10 power negative 3. Which one is smallest? Is it 10 power negative 2 or is it 10 power negative 3? Right? From your knowledge of integers, right? From your knowledge of integers of grade 7. If you take the number line, you have 0. To the right, you have positive integers, 1, 2, 3 and so on, positive. And to the left, you have negative integers. Okay? Now, as we move along the number line from left to right, as we move in this direction, the number gets large and large. Yes or no? The number becomes larger and larger. And as we move to the left, the number becomes smaller. Right? When we move to the right, the number becomes large and large. So in this case we have, let us consider the powers only. Take the powers only. Negative 2. So our number line is here. This is 0. Negative 2 somewhere here. And the second power is negative 3. Right? If we move to the left, we say that negative 3 is smaller than negative 2. Negative 3 is smaller than negative 2. Or simply, negative 2 is larger than negative 3. Right? So here the smaller number is -3. So -3 is smaller in this case. So we have to take out 10 power -3 as common factor. Right? So before taking 10 power -3 as common factor, we have to write the question as simply 5.2 times, now this 10 power -2, we can write it as simply in terms of 10 power -3 as 10 power -3 times 10 power 1, because if you add these two powers, -3 plus 1, it's going to give you -2, right? So this is the little trick here. And plus this second number remain as it is in terms of 10 power -3. Now we see clearly 10 power -3 is common. So we take out 10 power -3 out. So we are left with 5.2 times 10 power 1, which is 10, plus 4.2. Okay, and we continue. This gives 10 power -3 times 5.2 times 10. It is simply 52 plus 4.2. I carry on there. 52 plus 4.2. It is 56.2. Right, and don't forget the 10 power -3 times 10 power -3, of course. Now we have to check, is this answer in standard form? We consider the first number. Is it between 1 and 10? No. So we have to convert this number between 1 and 10. But first we keep the 10 power -3 there. So let's convert 56.2. We bring the decimal here. So it's 5.62 times 10 to the power of 1. Now we apply the multiplication law of indices for this part. It gives times 10 to the power of -2. Right? So this is it. When you are dealing with negative power, your knowledge of indices is very important. Okay, so we have got the same answer, 5.62 times 10 power -2 using ordinary method. Again the same answer using factorization as well. Okay, now what about the difference? The same principle applies, but instead of using addition, we are going to subtract, right? So let us see this example using the first method, ordinary form. We have 5.9 times 10 to the power 4 minus 3.8 times 10 to the power 3. Now both powers are positive. When both powers are positive, the question is easy, right? No need to worry about. So this can be written as 5.9 times 10 power 4 is 10,000, right? Minus 3.8 times 10 power 3 is 1,000. And let us convert both numbers in ordinary form now. 5.9 times 10,000, right? Let me include some zeros, then I will move the decimal 1, 2, 3, 4 by 4 decimal places. 1, 2, 3, 4. So here it is. So this is simply 59,000 minus 3.8 times 1000. Now I include some zeros, then I will move the decimal by 3 decimal places. 1, 2, 3. So this is simply 3,800. I subtract these two. 59,000 minus 3,800. This will give 55,200, right? And now we have to write this number in standard form. Okay, 55,200. The decimal is here. We move the decimal until we reach a number between 1 and 10. 1 decimal place, 2 decimal places, 3 decimal places, 4 decimal places. So it's 5.5200 times 10 to the power of 4, right? Or simply you can write it as 5.52, because the 0 at the end you can omit the 0. Okay, so it's 5.52 times 10 to the power of 4. Okay, now the same question using factorization, right? So we have 5.9 times 10 to the power of 4 minus 3.8 times 10 to the power of 3, right? We have to spot the common factor. The common factor is the smaller number, right? And here, which one is smaller, 10 power 4 or 10 power 3? Of course, 10 power 3 is smaller, meaning it is common, right? So the common factor, the common number is 10 power 3. So we keep 10 power 3 as it is, and we must write 10 power 4. This 10 power 4, we must write it in terms of 10 power 3. Right? How can we write 10 power 4 in terms of 10 power 3? 10 power 4 is simply 10 power 3 times 10 power 1. Okay, so we write this as simply 5.9 times 10 power 3 times 10 power 1 minus 3.8 times 10 power 3. Now we can clearly see the common factor, 10 power 3, and we are left with 5.9 times 10 power 1, which is simply 10, minus 3.8, and this is simply 10 power 3 times 5.9 times 10 is 59 minus 3.8. So I continue there. This is simply 10 power 3 times, what about 559 minus 3.8. Let us subtract. This is 8. This becomes 2. 8 minus 3 is 5. Okay, this is 55.2, and this is simply 55.2 times 10 power 3. Now we have to check whether this is in standard form. This number is not between 1 and 10, so we have to convert it between 1 and 10. We keep the 10 power 3 as it is, So let us convert this number between 1 and 10. We move the decimal to the left. So 5.52 times 10 power 1. And now we have to use multiplication law of integers for these two. We have 10 power 1 plus 3, which is 4. Right? So our answer, as in the previous method. Okay? Both methods will give you the same answer. Now let us take an example of difference again, but with negative powers. Right? The first method, again, we are going to use ordinary form. Right? So we have 4.9 times 10 power negative 2 minus 3.4 times 10 power negative 3. Right? The first step is to convert the negative power as positive by taking the reciprocal. This becomes 4.9 times 1 over 10 power 2 minus, we do the same for the second number. The 10 power negative 3 can be written simply as 1 over 10 power 3. We continue. 4.9 times 1 over 10 power 2 is simply 1 over 100 minus 3.4 times 1 over 10 power 3 is simply 1 over 1000. Right? So I continue there. 4.9 times 1 over 100 is simply 4.9 over 100 minus the second one, this is simply 3.4 over 1000. Right? 4.9 over 100. I include some zeros to the left, then I will move the decimal 2 decimal places, 1, 2. So it is 0.049 minus the second one, 3.4 divided by 1000. Let me include some zeros, 1, 2, 3, 1, 2, 3. So this is 0.0034. All I have to do now is I subtract 0.049. I subtract 0.0034. Include a 0 here. Let us subtract. This is 8. 10 minus 4, 6. 8 minus 3 is 5. 4 minus 0, 4. 0, 0. So this is simply 0.0456. And now we have to convert this number in standard form by moving the decimal to the right. 1 decimal place, 2 decimal places. It's 4.56 times 10 power negative 2. Right? Now the same question but using factorization. Right? So we start, we have 4.9 times 10 power negative 2 minus 3.4 times 10 power negative 3. Right? Again, we have to identify the common factor. Always the smallest power is common, and here the smallest power is negative 3, because we have said from the number line when we go to the left on the number line, the number gets smaller and smaller. So negative 3 is smaller compared to negative 2. So 10 power negative 3 is our common factor here. Right? So we keep the common factor as it is, 10 power negative 3. The trick is to convert this 10 power negative 2 in terms of 10 power negative 3. So 10 power negative 2. How can we write it in terms of 10 power negative 3? It is simply 10 power negative 3 times 10 power positive 1, because when you add negative 3 with 1, you are going to obtain negative 2. Right? So we write 4.9 times this 10 power negative 2 simply as 10 power negative 3 times 10 power 1 minus 3.4 times 10 power negative 3. Now we can clearly see the common factor, which is 10 power negative 3. We take it outside the bracket, then we write 4.9 times 10 minus 3.4. This is simply 10 power negative 3 times 4.9 times 10 is simply 49 minus 3.4. I continue there. What is 49 minus 3.4? 49, I subtract 3.4. This is 8, 10 minus 4 is 6, 8 minus 3 is 5, 4 minus 0 of course is 4. So this is simply 10 power negative 3 times 45.6. It is the same as 45.6 times 10 power negative 3. Now we have to check whether this is in standard form, right? We don't have a number between 1 and 10, so we have to bring this number between 1 and 10. We keep the 10 power negative 3, right? 45.6, we have to move the decimal to the left by 1 decimal place, meaning 10 power 1, and we use the multiplication law of indices, which gives 1 plus negative 3 is negative 2. Okay, so this is it, the same answer as in the previous method. Okay, so this brings us to the end of this session. I hope you have understood how to write down a given number in standard form and how to evaluate a sum and difference using ordinary method and as well as factorization method. Okay, till then, see you for the next session.